Okay, so just a quick little walkthrough of what we're going to see at the mill. I think I have footage of all this. Sorry, I'm recording this after the fact, but real quick, first is drilling the holes that I was going to hand tap for 1/4-20 to hold down the raw stock. Drilling the holes that'll eventually be for the tabs and the pivot. Boring a locating feature here. That's going to be what I locate off of for later stuff with this fixture. Thread milling the 1/4-20 holes. The smaller ones I'm going to do by hand. Just putting a little version numbering thing here. And then we move on to the second setup where I drill in the stock. I drill the holes for the tabs and for the pivot. Drill holes for where the jimping is. We'll see how some of this doesn't go exactly as planned. And I don't know why I have a spinning beach ball here. Looks like that might be Fusion doing that. Come on. Sorry, guys. Okay, as I was saying, holes drilled, holes for jimping drilled, and then boring out those four to as close to 1875 as I can, and then the big op profiling the whole thing, which I'm doing with the 3/16 5 flute end mill. And then, as you'll see later, I had to do one last operation to finally cut through the bottom, just because I think thickness of the material, variation, etc. But yeah, we'll look at some machine footage. So here we are, thread milling some holes in this fixture. These are the 1/4-20 holes that are going to hold down the stock by the edges. I meant to film some more earlier, but I had my hands full. I've already tapped by hand the smaller 832 holes that are going to be the ones that go through the tabs on the blade. I tapped that bottom left 1/4-20 by hand, and that took a long time to do it cleanly, so I was like, alright, let's do some thread milling. So I programmed that, and then, yeah, it seems like it's going smoothly. The feed rate is pretty slow, only about 8 inches per minute, and I'm doing it in 2 passes, so it's not taking that full depth to thread. I'm trying to minimize deflection, and I don't really have a sense for what the load this little thread mill is capable of, so, but, it's a couple minutes to run this off for 7 nicely coated holes. So let's take a look inside and see how they look. It looks good. Yeah, and there's a little burr at the top. So I'm gonna blow these out with some air, and ooh, that one's got a lot of junk in it. I think it was getting some of the detritus from the next hole. Here's the little locator pocket that I milled. Floor actually doesn't look very smooth, but it feels very smooth. Yeah, this is going to be my work coordinate origin once I deburr everything. So, in theory, come on, focus. In theory, our fixture is ready to go for sort of that whole first set of ops. So we're gonna clean it up, test fit all the bolts, and see where we go from there. All right, so here we are, having finished I think all the operations for now on this little fixture, and just kind of test fitting bolts and some stock in. So I'll spin this camera around and I'll show you what we're talking about. So this is a piece of 1/8 inch by 2.5. This is just some 303 stainless that I'm probably gonna, that got really cheap as a remnant. Should probably do some test cuts before I use anything for real. I'm going to cut this down so it's about 6 inches wide. That's sort of what I have in my CAD. So I'll set up the bandsaw for that. But yeah, I'm just using some little 3/8 inch high, 1/4 inch 20 bolts to hold in place, and it feels, famous last words, but it feels pretty secure. Looks like it's this piece is fairly flat. This is obviously not precision ground stock, but I think for again, for sort of what is probably a trial run, this will be okay. So let's go from there. Okay, so cut this piece down to size. My bandsaw needs a bit of adjustment, but whatever, that's for another day. Yeah, and let's see how well we can see this, but it appears to be holding pretty flat all the way around. I don't see any really any gap there, and it seems like there's like enough of a ledge. And obviously, like long term, I need a better fixture than this. We'll do something with pit bowl clamps instead of these, but I think for right now, it's fine. So I'm gonna go and do a little bit of CAD program, drilling all the little 3/16 holes for the tabs and for the pivot. Then I can mount this stock. I can bolt it down with those holes. I've already drilled and tapped the holes underneath. Hope everything lines up. And then, and then we'll try to profile out the blade. I have to still figure out around the perimeter, basically where there's jimping along the top of the blade near the pivot, and then along where the flipper tab is. Whether I just do simplify the model and take those features out for now, and then go back and do them later, or whether I actually drill those in now. Anyway, that's a question I'm gonna figure out, and then how to not have the profiling path to try to follow those. So that's a little thing to work on. But yeah, that's where we're at. So hopefully tonight I can figure that out. Okay, so we're just attempting to engrave the sort of model and version number of this fixture. I don't know if I set my engraving depth enough. I need to check the tool length actually again on this guy. Doesn't seem to be doing much. Alright, trying again. Let's see if we get anything. Yeah, it's going. The retract between moves is annoyingly high, but it's just a few letters of text. And this will let me keep track of what version of my CAD file this physical fixture is related to, because I know that I'll forget. And then as soon as this is done, we're going to mount the stock and try to drill and then bore those locating holes, well, the holes for the tabs and the holes for the pivot. I don't yet have a reamer for 3/16, so I'm going to use an 1/8 inch end mill and just try to sneak up on that right dimension, and I'll check it in between with some gauge pins and see how close I can get. Anyway, as soon as it stops, we'll take a look inside so we can see how the text looks. Come on, focus. Right there. I really just not want to focus on this. Let's try the wide angle. There we go. Anyway, this is 0.1 alpha. any of these sci-fi nerds, I'm you know, super into Dune. Always have been since I was a kid. I don't know this would be the final name for the knife if I actually, you know, were to sell them. But anyway, that's my working name. Anyway, this looks good. So we're gonna mount up some stock and then start cutting. Okay, so did our little fixture. Gosh, the focus, come on. Marking, and then mounted the stock back up. It's held nice and secure, and now we're gonna go and do some drilling, which I admit I'm a little nervous of because I'm more drilling in aluminum than steel. Although this is only 1/8 of an inch thick, I'm just like, you know, using some good estimate speeds and feeds, but probably be a little bit of a nail biter until I get there some. This is not, it's just a cobalt drill. It's not a carbide drill, but it's you know, it's stub length, so it should be fairly rigid. Anyway, let's hope for the best and see if we can get the camera rolling here. Okay, happy to report that all these holes drilled no problem, and they, you know, lined up right above the holes in the fixture that I drilled and tapped before, so it looks like we won't have any alignment problems. So now I'm going to switch to a smaller number 50 drill to drill holes for the jimping, because I think that's going to be easiest to do when this thing is still a whole piece. So I've got to change the bit and measure the height, and then we'll come back. All right, so we just finished drilling these holes for jimping, and let's take a look at what we actually got. So this upper row here, if I can focus, actually looks pretty good. Spacing looks even, nothing looks really ugly there. Can I zoom in on this? My focus. That's about as close as we get. I think that's gonna be okay. The one down here, it's kind of weird. It's like the second and third holes. I could see it was pulling the bit to one side. I think what happened, there was still a chip stuck in the drill, and it kind of, you know, when it was first engaging, it sort of wandered a bit. Anyway, ideally, and certainly in the next round of these, I'll do this with a shorter carbide drill. Okay, so I just ran the first of the boring operations. That's taken that number 29 drill hole and bring it up to, in theory, 1875 for these shoulder bolts that are going to hold it in, and they're fairly precise shoulder bolts, and I want the fit to be as tight as possible. So I've already checked this, but this is my 187 dowel pin, and you can see it does not fit, and in fact it was a 184 that fit. So, you know, I don't have an accurate way to measure tool diameter, at least not, you know, not automatically. So I just gone back into the code and added some compensation, you know, just negative stock to leave on the operation, and I'm going to run it again and see if we get to our desired size. So be back in a sec. All right, so here we're just enlarging those number 29 drill holes up to their final size, as close to 0.1875 as I can get, so that the shoulder bolts that I'll be holding the blade down with, you know, will locate nicely. I'm probably going to have to, what was I going to say, do a dowel pin hole as well along one of the edges of the knife as another locating source, just because I imagine that there's a bit of slop inherent in the threaded holes, just in the fit of those shoulder bolts. I think to get it a little more accurate. But hopefully these will be done soon. We'll check, you know, test fit them. Okay, after a little finagling, got all these shoulder bolts in place. I had to use some washers just to get, you know, I didn't drill or it didn't tap quite deep enough for the full length of this thing to engage, but I think the shoulder is engaged with the piece, and then still securing everything from the outside as well, so the stock just isn't flopping around while we're cutting. I had to remove this one because the profile path is going to cut pretty close to there as it comes around with sort of the flipper tab, and then anyway, so we'll crank this up in a second. Okay, so after all that to do, we're actually cutting the profile now. Pretty tight around these corners, especially now that I've added those washers in, but I haven't heard it rubbing against the washers anywhere, and yeah, so this is running pretty slow. It's only going at about 4 inches a minute at about 2,800 RPM. This is a 5-flute 3/16 mil Lakeshore carbide, and so this is going to just ramp around the profile, taking about 20 or 25 thou paths so we get through the whole thing. So it should take about 5 trips around, but yeah, that's what I'm doing for now, trying to get at least a decent finish so I don't have a ton of cleanup. So I'm starting to see the outline emerge, so that's cool. So it's still going. It's about, I'd say about halfway done. It's going nice and slow. Hopefully it's not work harder or anything, but I just finished the whole profiling operation. I suspect that it didn't go quite all the way through. Probably a thou or two deeper. I may just program a quick finish pass because, alright, well, let's find out whether is it good or not. Let's unclamp some of these 420s. There was so little chatter, it made me feel like it can't possibly have gone through. But then it looks like it did. I don't know. Let's get these guys off. Oh yeah, it's actually all the way through. Amazing. Like nothing was vibrant. Like I'm just surprised that my pretty lowbrow fixture here actually held everything still. Yeah, it's totally detached. Okay, I'm gonna take these out and then we'll have a look. Alright, well this might be our stopping point for tonight because we have successfully profiled this thing with the exception of those, those crappy jimping holes which we sort of knew about going into it. That's okay. But everything else was blow it off. It's kind of sticky because I'm using the mist instead of flood one. But yeah, I mean, this is still oversized because there's tighter corners I gotta get in here with a smaller mill and stuff. But yeah, I mean, overall the surface finish looks good, and this fixture actually held up quite well. So there we go.